Today we will start with Neuville condensation reaction. In aldehydes and ketones, we have already done first aldol condensation reaction, then cross aldol condensation reaction, then benzoin condensation reaction, and then Perkin reaction. So next is Neuville reaction. And thus we will be doing that it is closely related. It is closely related It is closely related to base catalyzed aldol condensation mechanism. That is, we have already done. In this, an aliphatic or aromatic aldehyde reacts with active methylene compound such as malonic acid, malonic ester, then cyanoactic ester, nitroalkanes, etc. in the presence of a base such as pyridine or piperidine to form alpha beta unsaturated compounds. So, in this, the aldehyde or ketone aliphatic aldehyde or ketone reacts with active methylene compound like this, that is in this CH2 group is present and X and Y group can be ester groups or other groups as we already discussed in the definition. So in the presence of base, that is pyridine or piperidine, they give condensation product, and in this alkene is formed, substituted alkene is formed. That is, this group, that is water, is removed and these two carbons are attached through double bond and we get substituted alkene. That is, these two groups remain the same and these two groups are here. So only water is removed and other groups are as such, and these two carbons are attached to the double bond. That is, we get substituted alkene. That is, if we take an example, if we take up an example, that is, this is an aldehyde in the presence of this malonic acid, that is a compound with active methylene group CH2, and these are the two carboxylic groups due to which this hydrogens are active. So this group is active methylene group. So when these aldehyde and malonic acid react together in the presence of pyridine or piperidine, then this water is removed and these carbons are attached to the double bond, so we get a substituted alkene, and then these two carboxylic groups are attached to the same carbon, so it is unstable and they go decarboxylation reaction to give this alpha beta unsaturated acid. That is, this cinnamic acid is formed. Similarly, if we take up another example, so if we take up another example, in that we have taken benzaldehyde with this ester, malonic ester, again this water will be removed and these carbons are attached to the double bond, and then these two ester groups are present on the same carbon, so this is unstable and this upon hydrolysis gives this upon hydrolysis gives this, that is, the ester groups are converted into carboxylic acid group, and then upon heating decarboxylation takes place and this one COH group is removed, that is, as CO2 group is removed and we get a alpha beta unsaturated acid, that it is, and in this case it is cinnamic acid. So the Neuville reaction, any aliphatic or aromatic aldehyde is treated with compound with active methylene group, and then the ultimate product is the alpha beta unsaturated carboxylic acid. So next is, as we already discussed, this is only for aldehydes. Now ketones with cyanoester ester group, that is which contain acidic more acidic alpha hydrogen atoms, can undergo this type of reaction. That is only ketones with compounds with CN group, cyanoester ester. They combine in the presence of piperidine, and upon heating, then again this water is removed and we get this substituted product, and then upon hydrolysis we give, upon hydrolysis, then this acid is formed in this first one acid is removed, carboxylic group carbon dioxide is removed upon heating, and we get alpha beta unsaturated acid, and in this case this is cyclohexylidene acetic acid. So this is Knoy-Vanigels reaction, and for this the mechanism is from base, that is pyridine or piperidine. Base abstracts combines with this hydrogen and is abstracts hydrogen, then these electrons moves to carbon, that is we get negative charge on this carbon, and negative charge on this carbon, that is the carboanion is formed, and this carboanion is resonance stabilized to give this compound in which these electrons move to this, and the carbonyl electrons move to oxygen, and we get O negative, and here the double bond, and then the carboanion formed, then the carboanion formed reacts with aldehyde, and it attacks the carbonyl carbon, then whole group is attached as such to the carbon. This carbon is this, and this CHCO, CH3CO, C2H5 as such, and O carries the negative charge, and this, then with removal of base, it gives then with BH, it gives a COCH3 as such, then COC2H5, and in this base is removed and we get OH carboxyl group, and then again with base again abstracts hydrogen, and these electrons move to in between these carbons, and double bond is formed, and other groups are as such, so it is alpha beta unsaturated compound. So the mechanism for Knoy-Vanigel reaction is first base abstracts hydrogen and carboanion is formed, and this carboanion is formed, and this carboanion is resonance stabilized, then this carboanion attacks the aldehyde, and this carbonyl carbon attacks the carbonyl carbon, and then this anion is formed, and this anion then combines with BH, in which B is removed and H gets attached to the O. OH is formed, that is hydroxy group is attached, and then with base abstracts the hydrogen, and here we get the alpha beta unsaturated compound, and this is the now carbon, and this is the final product in the Knoy-Vanigels reaction. So this is all about the Knoy-Vanigel reaction. In Knoy-Vanigel reaction, aliphatic or aromatic aldehydes react with compounds with aldehyde or ketones react with compounds containing the active methylene group, and then we get the last alpha beta unsaturated compound. So next is Mannich reaction. In Mannich reaction, the reaction takes place between active methylene compound and formaldehyde and amine, and amine is generally a secondary amine, is secondary amine in the presence of acid to give a product which with base gives beta amino carbonyl compound, which is known as Mannich base. Therefore the reaction is called Mannich reaction. So it is a reaction between compound containing active methylene, and these are usually enolizable ketone, that is ketones which can be enolized, and with formaldehyde secondary amine in the presence of acid to give a product which is called beta amino carbonyl compound. And the reaction is this is enolizable ketone. It reacts with formaldehyde secondary amine and acid HCl to give this product, that is C6H5C double bond O CH2, and these as a CH2 and this as a NHCH3 two times, and Cl negative is associated with this because the nitrogen carries positive charge, and then this with base gives the product that is called Mannich base. This product is called Mannich base with lastly with NaOH, in which positive HCl are removed as NaCl and water is removed, and finally the product which we get is called, it is actually alpha carbon and it is beta carbon, so it is a beta amino compound, and this is called Mannich base, and the name is beta dimethyl amino, 3 carbons are present, so propiophenone. So next is the mechanism. Mechanism is first the formaldehyde combines with acid H positive and the protonated is formed, and then protonated formaldehyde with secondary amine reacts, and in this lone pair of amine gets attached to the carbon, and these electrons move to the oxygen carrying positive charge easily, so the acid makes the reaction possible easily, and then the OH is formed from this. As electrons move to oxygen carrying positive charge, OH group is formed, and this secondary amine is attached to the this carbon, that is NHCH3 two times, and then with removal of water, that is OH from this, and H from this, we get the product, that is we get this as product which is resonance stabilized, and in this if these electrons move to nitrogen becomes neutralized, and the carbon will now carry positive charge, that is this, and this in which carbon carries positive charge, that is the carbocation, it acts as a electrophile. This acts as the electrophile, and now this attacks on the enolizable ketone, that is first already it also takes H positive, and protonated is formed, so, and which is dynamic equilibrium with this enol form. Now on this enol form, the on this enol form, the electrophile attacks through this carbon, that is these electrons form bond with this carbon, and these electrons move to carbon, so to complete its octet, so C double bond OH, and O will carry positive charge, and now it is attached as such against the CH2 and CH3 two times, and in this proton transfer takes place, and this proton is transferred to the nitrogen, and this we get then nitrogen will carry positive charge as H positive is moved here. So this with OH negative gives the final product. OH negative abstracts this hydrogen and makes neutral nitrogen, and this is the final product. So mechanism for the Mannich reaction is the first formaldehyde with acid gets protonated, and then this is attacked by secondary amine with nitrogen with lone pair attacks the carbon, and then this is formed in which meanwhile these electrons also move to oxygen, so that this nitrogen can attack a carbon, that is OH, and then this nitrogen is attached to this carbon with positive charge CH3 twice H, then water is removed and we get this as a product, and in this is resonance stabilized, so this can be formed, it is electrophile, so this electrophile or this can attack the ionizable proton, that is this ketone, ionizable ketone, meanwhile with acid forms this protonated ketone and this enol form. Now this enol form is being attacked by the electrophile, and this electrophile is attached to the carbon through these pi electrons, and these electrons of oxygen move to this carbon, and then we get this C6H5 C double bond OH, and now O will carry positive charge because electrons move to this carbon, and now and other group is attached as such. Then takes the proton transfer. In proton transfer, the protons is transferred from OH to this H, and then this with OH negative abstracts the hydrogen from the nitrogen, and we get here Mannich base. So this is the mechanism for Mannich reaction. So next is Wittig reaction. Wittig reaction is, it is a reaction in which aldehyde or a ketone reacts with phosphorus alide, that is alkylidene phosphorane, to give a substituted alkene, and this reaction is called Wittig reaction. In this reaction, aldehyde or a ketone thus reacts with phosphorus alide, that is P double bond C with two alkyl groups. This is phosphorus alide, that is alkylidene phosphorane. This is phosphorane group, and this is alkylidene. Alkylidene means double bond is present, so this double bond is present and two alkyl groups are attached. So it is phosphorus alide. It reacts with aldehyde or ketone to give this product, that is with in the presence of THF or ether to give this substituted alkene. In this oxygen combines with this group, and the remaining groups is attached to this carbon. So double bond C R dash, and this C6H5 three times double bond O is attached. So it is triphenyl. Phosphine oxide, and this is substituted alkene. So in this we get aldehyde or ketone reacts with, it is also called phosphorus alide, is also called Wittig reagent. Reacts with Wittig reagent in the presence of tetrahydrofuran or ether to give a substituted alkene. And thus the double bond O and combines with the triphenyl phosphorus, and other remaining group is attached to the carbon, so the substituted alkene is formed. So next is its mechanism. In its mechanism, the aldehyde or ketone attacks the carbon. Here is double bond O. Here was double bond O. If the electrons are moved to this, so this will have negative charge and this will have positive charge. So this carbon carrying negative charge, that is carbanion, attacks the this carbonyl carbon and electrons move to oxygen. So we get CO negative, CO negative, and two groups are as such this, and this carbon is attached to this carbon, that is carbon, and two alkyl groups are attached, two alkyl groups, and this group is present as this P positive C6H5 three times. So we have arrange these groups like this so that we can describe its further steps to be carried out. So this product formed is called butane, and then then the oxygen and phosphorus. Oxygen was carrying negative charge and this is positive, so they form bond, and then this cyclic product intermediate formed is further gives these electrons move to this and these electrons to this, so double bond is formed here and double bond is formed here, so double bond O, and this is double bond C, so substituted alkene, and this triphenyl phosphinoxide is formed. So this involves a cyclic intermediate in between the reaction. So this is the Wittig reaction in which aldehyde or ketone reacts with phosphorus halide, that is Wittig reagent, in the presence of tetrahydrofuran or ether to give a substituted alkene. And the mechanism is the aldehyde or ketone reacts with phosphorus halide to give this butane, and then it gives this cyclic intermediate and then the final substituted alkene. Now this reaction is very important. In this we can also mention, if we require, otherwise there is no need, that is how the Wittig reagent is formed. This is optional. That is, if triphenylphosphine reacts with alkyl halide in which two alkyl groups are present, uh, trialkyl halide with in the presence of benzene or ether gives this phosphorus this product in which can be used as a phosphorus halide or Wittig reagent. Now the main is the applications. This reaction is important and application can be asked, that is this Wittig reaction can be asked indirectly, that is if we know the substituted alkene, if we already know the substituted alkene, then we can write the reactants from which it can be formed. So the possible reactants can be asked for a given substituted alkene. That is, suppose the alkene, if suppose we have 2-methyl propene, that is 2-methyl propene is this 3 carbons and to second carbon methyl group is attached, so it is 2-methyl propene. So for this we can write all the possible reactants. How? In this we know that the reactants are aldehyde or ketone, and second is triphenyl phosphine or alkylidene phosphorane. Now in this one side this will be attached and to the other side this will be attached. So this can be attached to double bond O, and second must be attached to the C6H5 3 times P, triphenyl phosphine. So we can write the reactants as this, or we can write CH3 so this is formed as a product, side product, and this is the main product, 2-methyltropine. Similarly, if we have a this product, that is, it is 3-methyl 2-pentene. So in this case, all the possible products can be this can be attached to double bond O, then the other will be attached to the PC6H5 3 times. So other will be attached to the PC6H5 3 times, or this can be attached to this, that is the reverse can. This group is attached to double bond O, other is attached to the phosphorus P6H5 3 times. So two possible reactants can be written for a one product. So similarly, in this another example, if we have this product, then what can be the reactant? So this can be attached to the double bond O, or it can be attached to the phosphorus C6H5 3 times. So it can be attached to this group, or it can be attached to the this we can't see here. So there are two possibilities, that is, this is attached to the double bond, or this can be attached to the double bond. So these groups can be reversed. First, this cyclohexane containing double bond O, that is ketone group, cyclohexanone, is formed, or this group can be attached to phosphorus C6H5 3 times. So this is all about the main condensation reactions, and then we will continue with other topic in the next lecture. So thank you.